Hello, we're Team 4. I'm Joe Garces,
My name is Jorge Rosquete.
Catherine Gonzalez.
Lubutungola.
and these are our individual contributions. So for my individual contributions, I listed that I spliced the electric vehicle charger wire with an outlet adapter, as shown in the picture in the bottom right. We were connecting an electric vehicle charger with a wire that would allow it to be connected to wall plugs and other necessary devices for our application. So I spliced that together. Then we are trying to use a smart charger to be able to charge our battery pack. And we have been having difficulty with it. So I've been researching it, the Bolt Energy, and that's its item number. I've been looking into its specs, safety, and role in the battery ecosystem, from which I was able to find some manuals, including the one from the picture shown, which gives a better idea of where things are intended to connect and how they would better integrate into our own application. From this, I determined that part of the issue was the charger interlock, which has been giving us trouble. So I've been doing research on the charger interlock mechanisms, both this one and from other golf cart vehicles and similar vehicles. So I've been looking into their specs, their role in the battery ecosystem, and how we could possibly integrate it into our battery management system to see if it can fit, or if worst comes to worst, we might need to get a different charger or work around it somehow. So this is my contribution. Thank you.
All right, for my contributions to the project cover both technical and communication aspects. I worked on researching Bolt Heavy Duty 48-volt smart lithium charger, reviewing its specifications and safety features, and also a little bit of system compatibility. I also contributed and collected specifications of our tool, focusing on real-time monitoring and predictive accuracy transparency in the user interface, and environmental resilience. Another area I supported was defining the problem statement and project objectives, making sure that address the key challenges in battery diagnosis, and also conducted research on advanced diagnostic platforms such as NASA Benchmark and Cost Toolkit. Lastly, I helped coordinate and edit media for demonstration, ensuring our presentations were clear, consistent, and professional. That's all for my contributions.
So my contributions to the project included both research and hands-on hardware support. I tested the battery cells with a voltmeter to confirm they were safe and working properly. I also researched the EV charging station called Clipper Creek to understand its specifications, safety features, and role in EV infrastructure. In addition, I also researched the wave share for the HAT documentation to learn how to mount it on the Raspberry Pi, connect the antennas, and set up the SIM card. On the hardware side, I help wire the Raspberry Pi to the Orion BMS through a USB to CAN connection, verify power and signal consistency, and supported troubleshooting connection issues between the Raspberry Pi and the Orion BMS. Overall, I contributed with combining research with practical technical support to ensure a reliable setup. Thank you.
If my contribution being a remote student, I did a lot of research on the Orion BMS uh, uh, battery management system device, and also set up my own station here where I've installed a BMS utility software, and I also have a Raspberry Pi here so that I can help with the development of this project. And most of the project involve building the application, uh, implementing the machine learning, and so I'm ready for be part, contribute in that type of way from the setting I set up over here. And I researched a lot on the battery chargers that we're gonna use because this required different type of charger because the BMS should be able to communicate with the charger. And for that, we need to use a control battery charger. And that's my contribution. Thank you.